Good day, students. Today I want to solve a problem on empirical formula based on the oxide of nitrogen. Now, last class we solved problem that involved carbon, hydrogen, and oxygen, which is under empirical formula, and we have to determine the empirical formula and also deduce the molecular formula. You have to get the empirical formula before you can proceed by deducing the molecular formula. And also you can see that in this case it involves oxide of nitrogen and oxygen. Okay, you can see 70% it contains 70% of oxygen and 30% of nitrogen. Is that okay? 30% of oxygen, which is O, and 30% of nitrogen, N. Is that okay? We are given 70% of oxygen. You should know that the remaining 30% should be for nitrogen. Sometimes they will not give you the other percentage, but you do the subtraction by saying 100 minus 70. Okay, you now have oxygen, I have nitrogen. The percentage of oxygen is 70, that of nitrogen is 30. Is that okay? The next thing to do is to divide each of the elements by their atomic mass, which is given to us. Now it's 70 for oxygen, 70 divided by 16, and also nitrogen 30 divided by 14. 70 divided by 16, you have it will be equal to 4.38. 30 divided by 14, you have it will be 2.1. Is that okay? Now divide through by the smallest value. The smallest value is 2.1. Now 4.38 divided by 2.1 and 2.1 divided by 2.1. Okay, when you divide that, you're having 2.1 and you're having 1. Is that okay? From here, you can see that you can approximate this to be approximately 2. This one is 1. Okay, from there we have the empirical formula. To be equals to, since N will come before oxygen, when you are writing it down, N is 1, oxygen is 2, NO2. Empirical formula is NO2. And when you get that, we are told that the relative molecular mass of the oxide is 92. What you now do is that empirical formula, put it in bracket X is equals to relative molecular mass. Okay, now since you have it like that, now you have empirical formula to be NO2 X. What our relative molecular mass is 92. our nitrogen is 14. Okay, and you know that what we want to do now, we have gotten the first part to determine the empirical formula, which is this. The second one is to get the molecular formula. Okay, now to get the molecular formula, you have to get simplified by, you have to look for your x, which is 14 plus oxygen 2 times 16. You can see it. Get the value for x equals, sorry, our bracket will be here, equals to 92. 14 plus 32, x equals to 92. That's 32 plus 14, 46. 46, x equals to 92. Divide through by 46. 46 cancels 46. Our x equals, let's say 46 times 2. 2 times 6, 12. 2 times 6, 12. Carry 1. 2 times 4, 8 plus 1, 9. Okay. 46 here 1, 46 here 2. X equals to 2. You go back by getting our molecular formula, because molecular formula equals the empirical formula. Equals the empirical formula bracket x, now which is equals to, what the empirical formula that we have is NO2, close the bracket. What's our x? Our x is 2, which is N2O, you open the bracket, N2O4. Is that okay? Now you can see, by the time you get what each of these is, you come back to 92. Let's see. N2O4 equals 14. Atomic mass of 14. Atomic mass of nitrogen is 14. 14 times 2 plus 16 times 4. Let's see. 28 plus 16 times 4. 4 times 6, that's 24. 2. Carry 2. 4 times 1, 4 plus 2, 6. That's 64. When you add it together, 64 plus 28. 8 plus 4, that's 12. Carry 1. 6 plus 2, 8 plus 1, 9. That's 92, which is the same thing as this. 92. Okay? These are molecular formula. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.